Okay, tonight we have to talk about linear relations and functions. So what we're going to do is, how do you recognize when you have one of these linear relations or functions? So first of all, we'll do it by graph. If you're looking at the graph, it's pretty straightforward. It's going to be a straight line graph. So, straight line. That's how you recognize it. And then everything else, if it doesn't look like a straight line, everything else is going to be called nonlinear, okay? So everything else, nonlinear. So that takes in a whole lot of other different stuff. Alright, so you're going to recognize the graph. That's pretty straightforward. You're also going to be able to recognize it by the equation, okay? And when you look at the equation, you're going to see that there's one or two variables. We always talk about x or x and y, but it can be any two variables. We'll take some examples. So one or two variables. That variable, though, has no powers or no exponents for the variables, okay? And the variables are not in the denominator. And, oh yeah, they're not times each other. Not times each other. So those are the rules you want to remember. If you have two variables, you can't have x times y. So, let's just do a couple of examples. And you tell me whether or not you think these would be linear or not. So I had 4 over x plus y is equal to 3. Would that be a linear equation? And you'd look at that and you'd say, no way. And you're right. Okay, so let's try another one. What if you had x plus 3y squared is equal to 7? Linear or nonlinear? You look at that and you say, of course, that's not linear. I'm sorry, that's nonlinear. It is not a linear equation. So let's try another one. What if we had, what haven't we tried yet? Yeah, okay. X plus 3y is equal to 1 over 7. Is that a linear function or equation? And you'd say, well, yeah, sure it is. It's no problem. I have an x and a y. They don't have powers. The variables are not in a denominator. It's okay to have the constant be fraction, and it's actually okay to have the coefficients be fractions, okay? So this one is okay, that yes, it is a linear equation. And the last example would look like, what haven't I done yet? xy is equal to 4. That would not be a linear equation. Alright, so you ought to be good at that. Let's try something else. Okay, so earlier we talked about this new function notation where we're using f of x, okay, to name our function. And it can be a linear function if, it comes up with ordered pairs that make a graph of a straight line. So, the ordered pairs are going to come out to be x comma f of x, right? But remember, we're just really replacing y with f of x. So, for the most part, we're always going to write x comma y. And we kind of use these two things, f of x and y, interchangeably, okay? So sometimes you'll hear me say linear function because there's an f of x name for it. Other times we'll just go ahead and use y. They're fairly interchangeable, okay? So let's move on and go back to equations, okay? So let's go back to a linear equation. And we're going to have x and y now, okay? And we want to learn about standard form. And it's something that you've seen before. And I will remind you, it looks like this. ax plus by is equal to c. And there are a couple of rules to keep in mind. You always want to write it so that the a is positive, okay? You also have to make sure that a and b are both integers. Okay, so those coefficients are not allowed to be fractions. It won't change whether or not it's linear, but it just won't be a standard form. So we don't want fractions for coefficients. That ought to make you happy. And the other rule is, oh yeah, you don't want A and B not both 0. What would happen if they were both 0? Oh, guess what? 0 is equal to some constant. Well, that doesn't make any sense at all for a linear equation, so that can't happen. So it's just a little technicality there that we have to be careful. A and B can't both be 0, or we're not talking about a linear equation anymore. Alright, so let's do a little practice with this. Alright, I'm going to take this linear equation and write it in standard form. So I want both the x and the y on the same side. Oh yeah, I got a choice to make. Because of my negative 3 over 10, I don't want it to be negative. I could move everything to the right hand side, and that's okay. So let me do that. I'm going to go ahead and move it. So I have, let me put that there first, 3 over 10x plus 8y, and I'll move the 15 to the other side, so it becomes positive when it changes side. Okay, so now everything is good. I've got x and y on one side. I've got the coefficient of x is positive, which is good. What's wrong is I have this fraction 10. So what I have to do is multiply everything by 10, and that'll get rid of that fraction because I don't want fractions for my coefficients. So 150, we don't usually use such big numbers, but we can. 3x plus 80y. That would be a standard form for a linear equation. Alright, I'll give you one to try. It looks maybe familiar to you, this kind of format, but we want it in a standard form, so pause the video and we'll check our answers. Okay, that was pretty easy because we didn't have to worry about the fractions, and 3x minus y is equal to 9. Okay, the last thing we have to talk about is intercepts. I wrote it in big green letters because intercepts are so important to us and they're very powerful. And you're going to love it because they're very simple. Okay, so let's talk about these. Let's talk about intercepts, and we'll break them down. If we have an x-intercept, what is kind of the definition? Okay, the x-intercept is the point where the graph crosses the x-axis. Okay, so that makes pretty much sense. Let's see if I could draw a little picture for you. Let's say I have that. Let's say I have a line that's doing this. Forgive me for not writing x and y. There it is. Now, identifying the x-intercept would be right here. Okay, that's where the graph is crossing the x-axis. So that's my x-intercept. Okay, so how are we going to evaluate where? How are we going to find the intercept? Okay, and the clue, okay, for finding this intercept is what's the value of y at this intercept. So here we're looking at the intercept, and what's the value of y? And it'll be true for any line. Let's say I put another line out here. Here's a different line. Go for a different color. Like that. Again, here is an x-intercept for that line. What do they have in common? They have in common that the y value is equal to 0. Okay? So for both of those x-intercepts and for any x-intercept, kind of a definition, y is equal to 0. Okay? So that's really awesome. Then we can talk about y-intercepts. We're done with that. Let's talk about y-intercepts. Guess what? Those are where the graph crosses the y-axis. So we can do the same thing. Let's see if I can find some more colors. If I go here and I go here. Okay. Where are the y-intercepts on this graph? I have two. I have the one here for the black line graph, and then I have a y-intercept here for the blue line graph. What do those 2 points have in common? Okay, so this is the point where the graph crosses, let me get my English right, crosses the y-axis, and that should make perfect sense to us. Y-intercept crosses the y-axis there. Okay, so what's the specialness? What do they have in common? How are we going to figure out? It's the place where x is equal to 0. Okay, so that's what we're going to use in order to be able to find these intercepts. Okay, keeping those in mind, let's try something. Okay, let's go ahead and take this linear equation and see if we can find the intercepts for it. First, we'll go ahead and find the x-intercepts, okay? And that, of course, is when y is equal to 0. So we'll go ahead and take this equation, make the substitution that y is 0. Okay, I'm going to be very explicit this time. We don't have to be when we get better at this. Solving for x. X is -2. Now, here's where you got something very important to remember. An intercept, by definition, is a point. Okay? Points are always given as ordered pairs. So, you can say x is equal to -2. It's not a solution. It looks like a solution when you write it that way. We want to write it so it looks like an intercept. It looks like a point. So the way to write your answer is -2, 0, right, like that. That is the x-enterprise, the x-intercept. Okay, so that's x-intercept. Let's talk about the other one. Let's go and do a y-intercept. And of course we'll find the y-intercept by setting the x equals 0. Okay? So, starting back at the original equation, setting x equal to 0, minus 2 times 0 plus y minus 4 is equal to 0. Of course, that's just 0, so I have y is equal to 4. Okay, and again, I need it in an ordered pair. So 0 for x, right, because that's how we started, 0, 4 is the y-intercept. Okay, they must have their own separate ordered pair. They're two different points. They each have an ordered pair. Done. Okay, let me give you one to try. Alright, here's one for you to try. I want you to do it on your own, check your answer, and then I have one last thing to show you that's so powerful you're going to love it. So pause it. Okay, I have my two intercepts 5, 0 and 0, 2. I don't even have to label them. That's the great thing about putting them in the ordered pairs is I know by looking at those zeros that I've got an intercept there. Alright, let's do this last thing that's really cool. Remember those two intercepts, 5, 0, 0, 2. Okay, once you have these intercepts, one of the great things you can do with this is easily graph your equation by using those intercepts. So we had this one, 2x plus 5y minus 10 equals 0. It's really awkward to graph in standard form. And the best way to do it, if it is starting in this isn't even quite standard form, but it's close. Something like this is probably easier to graph it using intercepts than some other ways you might be thinking of. So, all I'm going to do is graph 5, 0. Put a big old honking dot there. I'm going to graph 0, 2. Okay? And then all I have to do is put a straight line between those. And the way you can do this, remember in geometry, 2 points determine a line. All I need is 2 points, and I can easily find 2 points, intercepts. So that's enough, and I have graphed the line. Done. Okay, see you in class.